Welcome to the deep dive. We're looking at a really monumental shift happening right now in the world of software. I mean, the kind of foundational change we probably haven't seen in decades.
Yeah, it's not just another update, is it?
No, definitely not. It's like a fundamental reimagining of how we interact with computers, how we create, how we build things.
From self-driving cars learning on their own to, well, programming computers just by talking to them in English. It's wild.
It really is. The ground is moving beneath our feet, digitally speaking.
It's an extraordinary time. You can really feel the transformation happening, and it touches, well, pretty much everything in tech.
And the pace. For so long, software development felt, I don't know, stable. But
Now
now,
it's accelerating like crazy, almost
okay.
dizzying sometimes.
Exactly. And that's our mission today. We want to do a real deep dive into insights from some of the, frankly, sharpest minds out there in AI and the startup world.
We're pulling wisdom directly from their conversations, right?
Yeah.
From places like startup schools.
Yeah, people like Andrej Karpathy, Andrew Ng, Aravind Srinivas, Elon Musk, Fei-Fei Li, Francois Chalet, Sam Altman, Satya Nadella. The list goes on.
And these aren't just people theorizing from afar. They're the ones building it.
Right. They're at the bleeding edge. Visionaries, builders.
What's so valuable is that blend. They have deep technical knowledge, but also that practical, often hard-won, entrepreneurial wisdom.
Totally. So if you're listening, maybe you're an entrepreneur looking for that next big thing, or a senior software engineer trying to adapt.
Or even a recent CS or computer engineering grad trying to figure out where you fit in this new landscape.
Then this deep dive is definitely for you. We're going to unpack not just what's changing, but really what it means for your career, your projects, your future.
Okay, let's get into it. Let's peel back the layers.
Right. Let's start with how software itself is changing. Andrej Karpathy, formerly head of AI at Tesla, right? He points out something pretty striking. For like 70 years, software didn't fundamentally change all that much. And then boom, in just the last few years, it's shifted twice. Rapidly.
It's a crucial observation, especially coming from someone who saw it firsthand. He breaks it down into these paradigms. Software 1.0 first.
That's the classic stuff, right? The code we write ourselves.
Exactly. Explicit code, written line by line. Think C++ in Tesla's Autopilot initially. Every single instruction, meticulously crafted by a human.
So if you wanted the car to see a stop sign back then, you'd write complex rules in C++i, detect the shape, the color, the letters.
Precisely. Very deterministic, but also very rigid, hard to adapt to every possibility.
Okay, then came software 2.0.
Right. Neural networks, deep learning, this is different. You're not writing the rules anymore.
You're feeding it data.
Exactly. You curate massive data sets, and an optimizer learns the parameters, the weights of the network from that data. Karpathy saw this transformation at Tesla.
He said the neural nets started eating the C++ code.
Literally. As Autopilot got better, the neural net parts grew, and the old software 1.0 C++ code was actually being replaced.
Wow. What kinds of tasks did that enable?
Things like complex image recognition, identifying cars, people, lane lines, that stuff moved from C++ to neural nets.
And stitching together information, like from all the cameras.
Yeah, building that cohesive picture of the world around the car. That also shifted to software 2.0. It was just better suited for those kinds of perception and sensor fusion tasks. A real light bulb moment for him, I think.
And now, another shift. Software 3.0, his pinned tweet, right? Remarkably, we're now programming computers in English.
That's the one. Powered by large language models, LLMs. Now, instead of writing C++ or training weights, you're just talking to the model.
Using natural language.
Oh,
English, mostly.
Yep. You prompt it, you instruct it, and it generates stuff, text, code, even whole applications. The interface is becoming incredibly intuitive.
So for anyone listening, a student, an engineer, an entrepreneur, what's the takeaway from these three paradigms? Do you just pick one?
No, quite the opposite. Karpathy really stresses this. You need to be fluent in all three,
All three. Why?
because each has its strengths and weaknesses.
Yeah.
You need to fluidly move between them. You'll constantly be asking yourself, okay, for this task, should I train a neural net? Can I just prompt an LLM? Or does this critical piece need explicit, deterministic software 1.0 code?
So it's like being trilingual in software development, a new core skill.
Exactly. It's a fundamental shift in how you approach problem solving with code.
And this software 3.0 with LLMs, it's not just a programming style, it's creating new infrastructure models too.
Yeah.
Karpathy compared them to public utilities like electricity.
Yet it echoes Andrew Ng's famous line, AI is the new electricity. Think about it. Companies like OpenAI, Google with Gemini, Anthropic, they spend billions in capital expenditure, the CapEx, just to train these models.
Like building the power grid.
Exactly.
Yeah.
And then there's the operating expenditure, the OpEx, to serve that intelligence through APIs. You pay per million tokens, kind of like paying per kilowatt hour.
And you expect reliability, right? Low latency, high uptime, consistent quality, just like electricity.
Absolutely. And just like you might switch electricity providers or use solar sometimes, there are services like OpenRouter now that let you switch between different LLMs easily.
Ah, so you're not locked into just one provider.
Right. And they don't compete for physical space, which is interesting. Karpathy also highlighted the downside of this reliance, though, when major LLMs went down recently.
An intelligence brownout.
That's what he called it, like unreliable voltage from the grid. He joked the planet just gets dumber because we're starting to rely on these things so much.
That's a bit scary, actually. So utilities, okay. But he also compared them to fabrication plants. Fabs, why?
Well, again, the massive CapEx is part of it, just like building a semiconductor fab. But also, there's this rapidly growing tech tree of R&D.
Meaning the core research.
Yeah, the cutting-edge stuff, new architectures, training techniques, AI capabilities, it's becoming really centralized within these big LLM labs. That concentration of research and massive compute power gives them this industrial fab-like quality. It's where a lot of the fundamental breakthroughs are happening now.
Okay, so if these foundation models are like utilities, like fabs, centralizing a lot of the core AI power, where are the real opportunities for entrepreneurs, for developers? A lot of the buzz seems focused down there on the chips and models themselves.
Right, and this is where Andrew Ng comes in with a really clear perspective. He's built tons of AI companies, right?
Yeah, AI fund.
He asserts that, well, yeah, the chip companies, cloud providers, foundation model folks get the headlines. Almost by definition, the biggest opportunities have to be at the application layer.
Why? By definition, that's quite strong.
Because applications are what generate the revenue. They're what users actually pay for. That revenue flows back down to support the whole stack, the models, the cloud, the chips.
Ah, okay. So without useful apps, the rest doesn't have a sustainable business model.
Exactly. So if you're building a startup or even just a new feature, your focus should be on how AI solves a real problem for users. That's where the value is created, where the economic leverage lies. That's the biggest playing field.
That really shifts the focus. It's about making AI useful, not just smart. Which leads us perfectly into building with AI. Andrew Ng highlights agentic AI. He calls it maybe the most important trend right now.
He does. He contrasts it with how we often use LLMs now, like asking someone to write an essay in one go, no backspace allowed.
Which is not how people work on anything complex.
Right. Agentic AI is more human-like. It's iterative. Ng's example is great. First write an outline, then do web research, then write a draft, then critique the draft, then revise it.
Like a loop, break it down, research, draft, review, improve.
Precisely. This loop, even if it feels a bit slower, gives a much, much better result for complex stuff. Ng says for things like compliance documents, medical diagnosis help, legal reasoning, these agentic workflows are often a huge difference between it working versus not working.
So essential, not just nice to have for tricky tasks.
Pretty much. And he notes there's now this emerging agentic orchestration layer, tools that help developers coordinate these multi-step AI interactions more easily.
Okay, so we're moving beyond single prompts. And Andrej Karpathy talks about something similar with partial autonomy apps, where humans verify the AI's output.
Yes, exactly. It's all about that rapid generation verification loop. Get the AI to generate something, have the human check it quickly, then iterate.
And he really emphasizes GUI's graphical interfaces for speeding up that verification part.
He does. His point is simple. Our brains are wired for visual processing. Looking at stuff is fun, and it's a highway to your brain, he says. Reading walls of text is hard work, but looking at a visual representation, much faster, more intuitive for auditing what an AI has done.
Makes sense. Trying to review a massive code dump from an AI would be a nightmare, which leads to his point about keeping the AI on a leash.
Yeah, you don't want these agents going wild, producing massive, unmanageable outputs that just become a human bottleneck, like that 10,000-line code diff example.
So how do you keep it on that leash?
Small, incremental chunks of work. Concrete, specific prompts. That increases the chance the output is good, verifiable, and useful. He connects it back to Tesla Autopilot, fundamentally a partial autonomy system.
And he cautions this isn't just a phase, right? The decade of agents, not just 1 year. Humans stay in the loop.
Definitely. Which fits his Iron Man suit analogy perfectly. Build augmentations where Tony Stark is still driving, not fully autonomous robots that might go off the rails.
I like that. The autonomy slider concept, too, let the user decide how much control to hand over and gradually increase it as trust builds.
It was about empowerment, enhancing human capability, not just aiming for full replacement right away.
Okay, this leads to another mind-bending idea, just-in-time software. Sam Altman talks about a future where software is just generated when you need it.
Yeah, forget packaged software. Your computer becomes this agent. It has access to your data, uses APIs for control, and the LLM is the interface.
So if you need to do something complex, the LLM might literally write a small custom app just for that task, right then and there.
That's the vision. And Satya Nadella echoes this. He sees users preferring to make software just in time. Tools like VS Code or even Excel become these canvases.
Canvases where you interact with an AI model, the best analyst, to create what you need.
Exactly. Less about learning menus and commands, more about just stating your intent in natural language. Altman describes this future interface as one that almost melts away.
Melts away. How so?
It's proactive, running in the background, understanding context, knowing when to step in and help, integrated across everything. He compares it to the AI in the movie Her.
Ah, that deeply personal, almost invisible OS. Which explains why OpenAI brought in Jony Ive, the designer.
Right. It's about fundamentally rethinking human-computer interaction for this new era. And a key piece of this is memory in ChatGPT.
So the AI can actually get to know you.
Yeah, remember preferences, past conversations, context. Integrating with your personal data, email, calendar, maybe even your Amazon account is crucial for it to become that truly useful personal operating system.
This personalization has huge implications for education, too. Though Karpathy sounds a bit skeptical about just asking an AI to teach me physics.
He thinks the AI just gets lost in the woods with that kind of open-ended request. His solution is more structured, keeping the AI on that leash.
2 apps, right? One for the teacher to create the course structure.
Using AI, but guided by a human-defined syllabus, making it auditable. And then a second app for the student to consume that structured AI-generated but human-overseen content. It maintains quality control.
Andrew Ng seems more focused on the hyper-personalized aspect, though.
He sees that as the big trend, yeah. Lots of experimentation happening now. The exact format is an avatar, a chatbot. It's still evolving. But the potential for tailoring education to each student is huge.
And Microsoft's seeing real results with Copilot in education already.
Apparently so. Studies showing it making a significant difference, especially in places like Africa and Latin America. It's a promising sign of practical application.
Okay, so we're seeing software becoming more conversational, generated on the fly, deeply personalized. The implications are huge. Let's pivot slightly to the entrepreneurs listening. Building a company in this AI era. Aravind Sumevis from Perplexity is pretty blunt. The only moat you have is speed.
He really emphasizes that. You have to innovate faster than everyone else, and Andrew Ng backs this up completely.
And calls execution speed a strong predictor of startup success.
Absolutely. And the exciting thing is AI tools are enabling this speed. And says best practices are changing every few months, so you have to stay agile and use these tools.
How much faster are we talking? Is it really that dramatic?
According to N, yes. For building quick prototypes to test ideas, easily 10 times faster, maybe much more.
10 times, wow.
Even for production code, he estimates AI assistance makes teams 30–50% faster. This isn't just a small boost, it changes the game. It lets startups build maybe 20 prototypes to test ideas, where before they could only manage 1 or 2.
That drastically accelerates learning and finding product market fit. And Engen also stresses the need for concrete ideas to achieve that speed. What does he mean by concrete?
An idea detailed enough that an engineer can just start building it. His example, use AI to optimize healthcare assets. That's vague, gets nods maybe, but it's slow to act on.
Because everyone might interpret it differently.
Exactly. Versus write software to let hospital patients pick MRI slots online to optimize usage. That's concrete. You can build it fast, test it fast, find out if it works fast.
So specificity equals speed. But Ng also talks about gut instinct. How does that fit in?
After you've done the work, explore the idea maze, talk to countless customers. He believes the subject matter expert's informed gut feeling can be a surprisingly good and fast way to make decisions, faster than gathering new data for every little thing.
So trust your informed intuition sometimes.
Yeah, especially in a startup.
Yeah.
His advice is pick one clear, concrete hypothesis. Pursue it relentlessly. If data proves it wrong, pivot instantly to another concrete idea with the same determination. Focus, execute, pivot fast.
That's great tactical advice. And Aravind Srinivas offers a slightly different take on starting up. Perplexity began without a clear idea. That goes against the usual advice.
It does seem counterintuitive, right? But it reflects this AI era. He says, don't change your idea weekly, but do brainstorm, build immediately, get it to users ASAP. The speed of iteration now lets you almost discover the product as you build it.
Sam Altman echoes that humble beginning vibe, too. OpenAI started as just 8 people, no product, no revenue. ChatGPT felt like sci-fi.
Yeah. His advice, pick a market that could be huge if some future version works out. They just put one dumb foot in front of the other for a long time.
Persistence. And that focus on a potentially huge, maybe even crazy future can attract talent.
Definitely. If you're doing something unique, something one of one that seems unlikely but incredibly valuable if it works, the smartest, most ambitious people might gravitate towards that because there's nowhere else doing it.
Okay, so you have this potentially crazy idea, you're moving fast. How do you find your niche and build a brand?
Well, historically, starting niche is often the winning play, right? Airbnb with Airbeds, Stripe for developers, Coinbase for regular folks buying Bitcoin.
And that's even more true with AI.
Seems so. Because people will pay more for actual work done by AI, not just generic software. The advice is find a niche you're genuinely passionate about. Pull on that thread. Connect AI to proprietary data or systems in that niche. That can create a real moat.
And brand matters too. Srinivas says it helps you earn the right to survive.
Yeah, especially when you get bigger. A strong narrative, a clear identity like Perplexity focusing on accuracy and speed that helps you stand out, even when the big players inevitably start copying you.
Which they will, right, if it's a good idea.
Srinivas acknowledges that. Big, well-funded players will copy. He thinks Perplexity's browser approach is harder to copy than just a chat interface, though.
And he points out Google's innovator's dilemma here.
Right. Google can't fully embrace AI-driven direct answers because it messes with their core ad business. Plus, he noted that for a while, Google often had maybe the 4th or 5th best models. That gave startups using models from OpenAI or an unprecedented opening.
A real David versus Goliath advantage, in a way. But what about competing with OpenAI itself? Is Altman worried about crushing startups?
He says they don't want to. Their focus is the super assistant with ChatGPT. He encourages people to build on their platform, use their APIs, use things like sign in with OpenAI. He sees OpenAI as an enabling layer for an ecosystem.
That's reassuring for developers. And both Altman and Musk talk about being contrarian but right. That sounds incredibly hard.
It is. Altman shared that Musk told him GPT-1 was basically crap with 0% chance of success. Imagine hearing that. But pushing against the grain, having that conviction even when smart people doubt you, that's often where breakthroughs happen. It takes serious resilience.
So given all this change, how should companies hire? Altman's advice on resumes is pretty radical.
Yeah, especially for early startups. He says, ignore the prestige stuff, big company names, fancy colleges. Go straight to, what's the most impressive stuff you've done?
Look for tangible achievements.
Exactly. He likes young, scrappy, but clearly get stuff done people. The famous quote is, hire for slope, not y-intercept. Potential and learning speed over current status.
That makes sense in such a fast-moving field. And Satya Nadella looks for 3 core qualities at Microsoft.
Yep. First, clarity. Can you bring clarity to ambiguous situations? Crucial in AI right now.
Okay, second.
Energy. Do you create energy, bring people together to solve problems, or just complain? Collaboration is key.
And third.
Problem solving. Are you good at solving over-constrained problems? Can you figure out how to unblock things? He thinks leadership isn't something you grow into later. You need these qualities at every step.
Clarity, energy, problem solving. That paints a picture of the ideal AI age contributor. This all flows into the future of work. Karpathy's vibe coding programming in English, he's bullish on that.
Extremely. Calls it unprecedented. A gateway drug to software development. It lets non-coders build custom things.
Democratizing creation.
Totally. And Andrew Ng takes it further. He thinks everyone should learn to code now because AI tools make it so much easier.
Everyone. Even, like, a CFO.
Yeah. He argues CFOs, recruiters, talent heads, they all perform better if they can code, at least a bit. The ability to tell a computer exactly what you want, even using AI assistants, is becoming a fundamental skill for knowledge workers.
So it's about leveraging AI in your own domain, not necessarily becoming a pro developer.
Right. Which also changes the role of the traditional software engineer. Nadella sees them shifting towards being software architects.
Architects. What does that mean in practice?
It's about understanding the bigger picture, the metacognition of your repo, as he puts it, monitoring what AI agents are doing to the code, overseeing the whole system.
Having that high-level view, managing the human-AI collaboration.
Exactly. And he stresses that legal liability stays with humans, so you need robust tools for that human-in-the-loop oversight, quality control, responsibility.
Which is sobering when you hear stats like CS major unemployment being higher than art history recently. The safe path is changing.
It really is. The How to Spend Your 20s talk highlighted that. And it makes you question university programs that ban AI coding tools, right?
Yeah, they're literally stopping students from learning essential future tools.
The new imperative for grads isn't just following instructions. AI is great at that. It's developing agency, independence, deciding what to build.
That requires a certain mindset. Fei-Fei Li calls it intellectual fearlessness.
Yeah, she attributes her own success, like with ImageNet, to going after problems that are just so hard-bordering delusional. She looks for that courage in young people.
Embracing the really hard, seemingly impossible stuff.
And for PhD students, she advises finding North Stars in academia that industry isn't already pouring resources into, like interdisciplinary AI for science, or pushing theory where AI capabilities have outrun our understanding. Find the gaps.
Go where the uncharted territory is. That resonates with Elon Musk's focus on being useful and doing true work.
Musk started Zip2 just wanting to do something useful on the internet. His definition of true work is about maximizing your total positive utility for society times the number of people you affect.
And to do that, you have to smash your ego.
Yeah, do whatever it takes, take responsibility. He warns a high ego-to-ability ratio, breaks your feedback loop, your RL loop, stops you from learning from reality.
So ego gets in a way of improvement.
Exactly. And he lives this with his first principles thinking. Building that AI training center, he broke it down. Building, power, cooling, cabling, solved each piece, even slept there and did cabling himself. Pragmatic problem solving.
That commitment to reality extends to AI safety for him, too. Rigorous adherence to truth.
He believes that's the most important thing. Don't force AI to believe untrue things, even if they're politically convenient, because that could make it dangerous.
Andrew Yang frames it slightly differently, though. Responsible AI rather than AI safety.
Yeah, and Ng argues safety isn't inherent in the tech, but in how we apply it. Like an electric motor, it's the application that makes it safe or unsafe, puts the onus on developers and deployers.
Right. And Nadella worries the hype overshadows the real-world benefits happening now.
He points to things like an Indian farmer using a WhatsApp bot built with an LLM to get subsidies. These underhyped stories show AI making a real difference. He emphasizes we need to earn social permission to use all the energy AI consumes by proving it creates real social surplus and growth.
Which circles back to the interface. Altman sees it melting away.
Becoming this persistent, proactive companion. And Nadella sees Copilot in Windows as a new browser moment, where voice and vision become primary inputs.
The dream being the agent just becomes your computer, doing the work for you.
Yeah, with trust, precision, privacy, reliability being absolutely paramount.
So looking even further ahead, AGI, abundance. How do these leaders see that? Fei-Fei Li kind of questions the whole AI versus AGI distinction.
She sees it as one continuum. The science of creating machines that can think and act intelligently, maybe even more so than humans. Nadella, though, avoids anthropomorphizing.
He sees AI purely as a tool, not replicating human thought.
Right. It shows signs of intelligence, but it's not human intelligence. Human agency remains critical in guiding it.
And Francois Chalet has this interesting take. Just scaling up current models won't get us to AGI. He talks about two types of abstraction.
Yeah. Type 1 is value-centric, pattern recognition, intuition. What today's models like transformers are good at. Recognizing images, understanding sentiment.
And type 2?
Program-centric, discrete logic, exact structure, reasoning, like refactoring code or mathematical deduction. He argues transformers fundamentally struggle with this, even simple things like sorting a list reliably.
So the missing piece is this discrete program search, something beyond just pattern matching.
That's his argument. His lab is building a system that learns like a programmer, evolving a library of reusable code blocks, aiming for genuine invention, not just automation.
Meanwhile, Elon Musk thinks superintelligence AI smarter than any human at anything is quite close. Maybe even this year or next.
He does. And he sees it leading to an economy potentially millions of times bigger. He also predicts multiple AIs, maybe 5 to 10, offering choice, which he sees as good.
And these AIs will do science, discover new things.
That's the vision. Sam Altman is also hugely excited about AI for science, seeing it as the key to sustainable economic growth, leading to incredible advances for everyone.
But the big bottleneck is energy, right? Both Altman and Nadella hit this hard.
Absolutely. Altman now sees energy as the fundamental limiter. He even muses about putting GPUs in space eventually because of Earth's heat limits.
Wow. And Nadella keeps coming back to needing that social permission for energy use, earned by creating value.
Altman compares AI's potential impact to the transistor, a foundational invention that ramped up quality of life massively over decades. He thinks AI will be even faster, steeper.
A truly transformative era. And Fei-Fei Lei adds another dimension: spatial intelligence. AGI needs to understand the 3D world.
She argues it's essential, something LLMs miss. Her lab works on world models for understanding and interacting with physical space. Applications in design, robotics, gaming, the metaverse. It's about AI grasping our physical reality.
And finally, the quantum connection. Microsoft's big bet. Nadella mentions stable, error-corrected qubits.
Yeah, that's a huge breakthrough. Think of qubits as the building blocks for quantum computers. They're usually incredibly fragile and error-prone. Getting stable, error-corrected ones is like finally having reliable bricks to build with. It makes practical quantum computing seem much closer.
And AI helps get us there.
Nadella sees AI as an emulator for quantum systems. Using high-performance computing plus AI is already speeding up discoveries in chemistry and material science. The dream is this loop: AI plus quantum plus HPC, all working together to finally understand the language of nature.
An incredible potential synergy there? What a journey through these ideas. From Karpathy's software paradigms, Eng on speed, Srinivas on niche, Musk on usefulness, Lan on fearlessness, Cholet on abstraction, Altman on superintelligence, Nadella on tools. The message is clear. Massive change, massive opportunity.
It really is. And the common thread isn't just the tech, it's the mindset. Adaptability, speed, focus on real problems, learning to wield these powerful but imperfect tools. For you listening, the human elements, critical thinking, agency, purpose, they're more important than ever.
Absolutely. As engineers, entrepreneurs, students, you are right at the thin edge of the spear, building a future most people can't even imagine yet. The real question isn't if AI changes everything, but how fast you can learn to use these tools effectively.
And are you building something genuinely useful?
Yeah.
Something that solves real human problems, not just a cool tech demo.
Exactly. How will you actively shape this revolution, ensure it creates that abundance, enhances human life, rather than just automating jobs away? That's the grand challenge and the incredible opportunity right in front of us.